Okay, in today's video, we're going to talk about plumbing sanitary riser diagrams, and we'll first discuss the main terms in plumbing sanitary systems, including what vent stack, a stack vent, waste, and soil piping are, as well as some other terms as defined in the New York City Plumbing Code. Then we will discuss drainage fixture units and how they are used to size sanitary pipes. And also, they can also be used to size vent piping as well. We'll also go over laying out and sizing of the vent piping, as well as sizing the sanitary pipes. And then we're gonna lay out the sanitary rise diagram based on an example plumbing floor plan, which will basically be at the end of the presentation, and we'll basically apply everything that we're discussing in this presentation. Okay, so these are the plumbing definitions. Plumbing definitions can be found in the 2022 New York City Plumbing Code Chapter 2 under definitions. And that could be found here. Just do a search for New York City Plumbing Code, and then once you get to this section here, it's Chapter 2 under definitions. So these are some of the main terms that I want to cover, which apply to this video. So soil pipe, a pipe that conveys sewage containing fecal matter to the building drain or building sewer. Fecal matter being the byproducts of digestion that will go into a water closet. Waste piping, the discharge from any fixture, appliance, area, or appurtenance that does not contain fecal matter. So it's everything other than what goes in a soil pipe. Waste pipe is just a pipe that conveys only waste. Sanitary, a drainage system that carries sewage or similar matter. So what is sewage? Sewage is any liquid waste containing animal or vegetable matter in suspension or solution, including liquids containing chemicals in solution. So basically, sewage can include animal matter, which could be fecal matter, or vegetable matter, which could necessarily be kind of like a waste product too. So sewage seems to be an all-encompassing term that covers both waste and soil. And sanitary contains sewage, so sanitary would basically be all-encompassing to cover both soil and waste material. Now you have two separate type of vent systems. One is a vent stack, and the other is a stack vent. So let's cover the general term first, which is the vent system, which is a pipe or pipes installed to provide a flow of air to or from a drainage system, or to provide a circulation of air within such system to protect trap seals from siphonage and back pressure. So a vent system is basically, if you look at a diagram such as this, the vent would be this right here. Okay, that is providing air to the P-trap here. So as you can follow this vent line, it's providing air to this P-trap here, as well as here too. So without this vent, what happens is this P-trap can actually siphon out, which means that if enough water is flowing through this and it doesn't have a vent, it can actually drain out the water seal in this P-trap. And without a water seal, you have basically exposure to the sewage system, to the indoor conditions. So basically the sewage gases can actually end up in your living space without this trap seal. So you want to maintain that trap seal. And the way it's done is basically with these vents. So a vent stack is a vertical vent pipe installed primarily for the purpose of providing circulation of air to and from any part of the drainage system. Stack vent, the extension of a soil or waste stack above the highest horizontal drain connected to the stack. So vent stack is a vertical pipe. Okay, it's basically this pipe here would be a vent stack. It's a separate pipe that goes all the way up and is connected to the bottom of the stack. Whereas a stack vent here is actually just an extension of the waste stack here. So one is just an extension of the waste stack, so it's this small piece here, in which all the vents are connected to, such as on this floor as well as the floor below. And for a vent stack, which so not a stack vent, but a vent stack is one that has a separate pipe, a separate riser that connects from the bottom and then attaches to the top of the waste piping. So that's the difference between a vent stack and a stack vent. Now, a trap is a fitting or device that provides a liquid seal to prevent the emission of sewer gases without materially affecting the flow of sewage or wastewater through the trap. So this trap is basically what they're referring to as the P trap here. Okay, these P traps. So this section, PC 904, Plumbing Code 904, talks about the vents. So required vent extension. The vent system serving each building drain shall have not less than one vent pipe that extends to the outdoors. So before I want to discuss these other terms here, there's a difference between the building drain and a building sewer. And the difference is the building drain is the lowest horizontal waste pipe, or the lowest sanitary waste pipe in a building is the building drain. And the building sewer is basically the extension of the building drain outside the building wall that extends to the city sewer piping, and it basically starts 5 feet outside of the exterior wall of the building. So the building drain is the lowest waste pipe that extends basically 5 feet outside the building wall, exterior wall. And then after that, it's considered the building sewer, and this would actually go to the city sewer system. So this is the difference between the two terms here. So going back to this, the vent system serving each building drain shall have not less than one vent pipe that extends to the outdoors. Installation. The required vents shall be a dry vent that connects to the building drain or an extension of a drain that connects to the building drain. Such vent shall not be an island fixture vent as allowed by section 916. Size. The required vent shall be sized in accordance with section 906.2 based on the required size of the building drain. You need at least one vent pipe that extends to the outdoors, such as in this diagram here, this would be the extension to the outdoors. So this flashing is basically on the surface of the roof, and this opening here would be above the roof and outdoors. So this is when a vent stack is required. A vent stack shall be required for every drainage stack that has 3 branch intervals or more. And a branch interval is basically defined right here. So a branch interval is a vertical measurement of distance 8 feet or more in developed length between the connection of horizontal branches to a drainage stack. Measurements are taken down the stack from the highest horizontal branch connection. So if this is the highest branch connection, horizontal branch connection, anything with 8 feet or more, such as here, this would be considered a branch interval. And anything less than that would not be considered a branch interval. So looking at this diagram to the right, which is for a larger building with more floors, you'll see that the branch interval is basically considered every floor. If you look here, this floor, which is a high ceiling floor, would be considered one branch interval as it's more than the 8 feet. So generally, you could consider every floor of a building a branch interval. So the vent stack is required for every drainage stack that has 3 branch intervals or more, or generally 3 floors or more. So in this case, you have 2 floors, so you can have a stack vent. So if you had 3 floors, then we would be required to add a vent stack, as it shall be required if it has 3 branch intervals or more. The vent termination, vent stack or stack vents shall terminate outdoors above the roof or to the stacked vent portion of the soil or waste stack, at least 6 inches above the flood level of the highest fixture connection, discharging into the soil or waste stack. That just means that this vent stack or stack vent, that just means that this connection to the waste stack or the sanitary riser stack here has to be 6 inches above the flood level rim. So the flood level would be the level at which any flooding would flood over the fixture. So in this case, it would be here. Flood level for this would be this point here. So 6 inches above the highest flood level will be for the lavatory, which would be at the surface level of this sink. And it has to be 6 inches above the flood level rim of the highest fixture connection discharging into the soil or waste stack. So this would have to be at least 6 inches from the highest flood level to the connection of the vent to the sanitary stack here. Vent connection at base. Vent stacks shall connect to the base of the drainage stack. The vent stack shall connect at or below the lowest horizontal branch. Where the vent stack connects to the building drain, the connection shall be located downstream of the drainage stack and within a distance of 10 times the diameter of the drainage stack. So you could basically connect it to the vent stack or to the building drain. So the way that it's shown in this diagram, it has to be connected below the lowest horizontal drain connection to the stack, which is here. So the way it's drawn in this diagram is correct. The other way is to actually connect the vent stack to the building drain over here. So we can actually connect it like this. And if that is the case, we have to follow this rule here, which is where the vent stack connects to the building drain, the connection shall be located downstream of the drainage stack and within 10 times the diameter of the drainage stack. So if this drainage stack was 4, it would have to be basically 10 times, which is 40 inches. So it has to be within the drainage stack, downstream, meaning down the direction of flow, 40 inches. So it's got to be anywhere in this range that the connection can also be made to. And there's a few more terms here, vent header and substack connection, but we're not going to cover this for now. So we covered the building drain, but this is the actual definition in the New York City Plumbing Code. Building drain, that part of the lowest piping of a drainage system that receives the discharge from soil, waste, and other drainage pipes inside and that extends 5 feet in developed length of pipe beyond the exterior walls of the building and conveys the drainage to the building sewer. And you can also have different types. You can have combined. So basically there's two separate types, sanitary and storm. So the sanitary is a building that conveys sewage only, and a storm is a drain that conveys stormwater but not sewage. So stormwater is anything such as rainwater that collects in drainage, in your front yard or your rear yard, or from roof drains. So that would be part of the storm drainage system. And if the storm piping connects to the sanitary piping and it basically goes into a common pipe, that common pipe is called a combined pipe. So it's defined as a building drain that conveys both sewage and storm water or other drainage. So looking at a diagram, it actually looks something like this, where this is the storm piping, which also requires a storm trap or a P-trap on this storm piping. And then you have a house trap, which is part of the sanitary system, and where they both combine and go out to a single pipe. This pipe is considered a combined pipe. One thing I would also like to mention is that the term waste piping is generally used very loosely, so they could sometimes call the soil pipe waste pipe. I may do it sometimes, and when you talk to some people, they might call just a soil pipe a waste pipe. So it seems like waste piping is just kind of like a commonly used term to represent, both waste piping and soil piping. So somebody might call this pipe a waste pipe where it contains fecal matter from this water closet. So by definition in the plumbing code, this would be called a soil pipe. So generally people will just call a waste or soil pipe just a waste pipe. So going through some more definitions, a building sewer, which we covered before, is by definition that part of the drainage system that extends from the end of the building drain and conveys to the discharge to the public sewer, private sewer, individual sewage disposal system, or other point of disposal. So basically, going back to the diagram, the building sewer would be this point here, extending 5 feet past this wall, where the building drain would basically end and the building sewer would start. A combined sewer, a sewer receiving a combination of sewage, stormwater, groundwater, and non-potable clear water waste. So here we have a private sewer, which basically means it's private to that building or group of buildings. Or you could have a public sewer, which basically means that you have multiple different building owners all discharging into this public sewer system. And then you have a sanitary sewer, a sewer that conveys only sewage. Storm is only conveying stormwater or groundwater and potable clear water waste. Okay, and if you want to see what the term of this clear water waste is, you could just look in the definition section of the plumbing code and it'll define what clear water is. But mainly, clear water is generally just things such as from RPC discharge or HVAC condensate discharge. So now we're going to talk about the plumbing drainage fixture units, and basically this drainage fixture units can be found in table 709.1 in the plumbing code. So if you go here, 709 is chapter 7, sanitary drainage chapter. And if you go to 709.1, so you could just do a control F, 709.1. It's right here, and this is the table 709.1 drainage fixture units for fixtures and groups. So it'll list the fixture type and the drainage fixture units that correspond to that fixture type, along with the minimum size of the trap. Now, the drainage pipe can't reduce in the direction of flow except for water closets. So the main rule is as you have the direction of flow in a sanitary pipe system, it always has to stay the same or increase. It can never reduce, and that is a code requirement. There is an exception here, which is 704.2. The size of the drainage piping shall not be reduced in size in the direction of flow. A 4 by 3 inch water closet connection shall not be considered a reduction in size. So you can actually have, for example, here, let's say it was a 3 inch being shown here as the drain piping from the water closet, rather than a 4. Let's say this was a 3. But the actual water closet came with a 4-inch outlet built into the fixture. That 4-inch to the 3-inch drain pipe would not be considered a reduction in size according to the plumbing code, section 704.2. But the company standard we use is a 4-inch water closet outlet, so that exception wouldn't even apply in our case. Based on drainage fixture units, sanitary pipe can be sized using 710.11, which is this table here, 710.11. And here it basically gives you the maximum number of drainage fixture units that can be connected to any portion of the building drain or the building sewer, including branches of the building drain, right here. So based on the fixture units, you could get the diameter of the pipe required. And also that number would change based on the slope. So for a given pipe size, you can have more drainage fixture units on that size the higher the slope is. For sizing horizontal branches and stacks, table 710.12 is to be used. So that's going to be the next table here, right here, to size horizontal fixture branches and stacks. So there's a difference between these systems here. And for building drains and sewers. And the minimum drain size that can be used in the plumbing system is 1 1/4 inch, and this is based on the code. Okay, now we'll talk about the plumbing vent system design, and that is using table 906.1. So going back to the plumbing code, you can go back to 9, which is chapter 9, and the table is 906.1, which is right here. And this will provide the size of stack vents and vent stacks based on the drainage fixture units. So the drainage fixture units are used to size both the sanitary piping as well as the vent piping. And the way it's done here is you have two columns. One here is for the soil or the waste stack. Okay, so this is the vertical piping. And you also have this other column here, which is total fixture units being vented. You have the maximum developed length of vent, diameter of vent. So based on, let's say you have 42 fixture units, you can have different pipe sizes here for the vent. So let's say you have a 2-inch. You can have a maximum length of 100 feet. Now, if you increase that size, the vent size, then you can have a further distance, because for that same drainage fixture units going through that pipe, you're going to have less of a friction loss with a larger pipe. So it can go further because of that less friction loss. All right, so that same table can also be used to size individual vents and branch vents. Developed length of these vents measured per 906.3. And that section is here, developed length. The developed length of individual branch, circuit, and relief vents. We're not going to cover these type of vents, but if you want to read up more on this, it's also in the plumbing code. Shall be measured from the furthest point of vent connection to the drainage system to the point of connection to the vent stack, stack vents, or termination outside of the building. So even though this table here says it's size and developed length of stack vent and vent stacks, it can actually also be used to size the individual vents and branch vents. And the individual vents would be these right here that are basically serving just a single fixture. So common branch vent sizing is based on section 906.4, and that states that where multiple branch vents are connected to a common branch vent, the common branch vent shall be sized in accordance with this section based on the size of the common horizontal drainage branch that is or would be required to serve the total drainage fixture unit load being vented. So going back here, the common vent would be something like this that runs across and serves multiple individual vents like here. And when you size this common vent, you basically have to size it for the total drainage fixture units that are served by that vent. So for example, this vent here, right, is serving all these units here. So the drainage fixture unit that you would use to size that common vent would be based on all of these drainage fixture units here that is basically served by that common vent. Minimum vent size to be 1 1/4 inch or half the size of the drain it serves, whichever is greater. So similar to the minimum drain size, which is 1 1/4 inch, the minimum vent size based on the code is 1 1/4 inch or half the size of the drain it serves, whichever is larger. So for example, here you could see that there are 4 inches here. So the minimum has to be at least half, right? So half of this drain pipe, which is 2-inch, or 1 1/4. Let's say we have a drain here, which is a 2-inch funnel drain, and here we see a 2-inch, right? So the minimum size of this would have to be half of the drain pipe, which in this case would be a 1-inch vent, or a 1 1/4 inch, whichever is greater. So in this case, for the 2-inch, the minimum size we would be using is 1 1/4 inch. But in this diagram we show a 2-inch, so we still comply with the code since the minimum in this case would be a 1 1/4 inch vent piping. You also need a fresh air inlet based on this section, which is at least half the size of the building house trap, but not less than 3 inches. So the fresh air is represented by this 3-inch FAI, which stands for fresh air intake, and it goes basically upstream of this house trap here. And this basically has to be sized half of the drain size here. So 4, it would be a 2 if it's half this. But then you also have to make sure that it has to be at least 3 inches. So in this case, we had to use a 3-inch fresh air intake. So let's say this drain pipe was an 8-inch. The minimum would have to be half of that, so a 4-inch fresh air intake. And since it's greater than the 3-inch, we would use the 4-inch fresh air intake in that case. Now there's some requirements for the building sewer in New York City. So basically, the 5 boroughs of New York City, excluding Manhattan, would require a minimum building sewer of 6 inches. And in Manhattan, the minimum building sewer would be 8 inches. So that sewer would be this pipe right here. Okay, so now let's begin on an example. And we're gonna go through this example here, and we're gonna create the sanitary riser diagram for this job. Okay, with the 3 floors and a roof and a cellar here. So to begin, we need to create the outline. So we need to create the floors. So I'm going to copy the one that was done for the water riser diagram. So I'll just copy this. All the notes here as well. The floor labels here. And this here. So I'm just gonna move that down here. We also need the exterior wall on this side, so I'm just going to copy this and move it to this side. Now I'm going to rename this to sanitary riser diagram. And it's not to scale, so I'm going to leave this note here. And I'll just center it. Now, if you look in the templates, we have some samples of sanitary riser diagrams that you can use. So we'll just use this one here. So I'm going to copy this along with the notes down here. And I'll just move it close to our sanitary riser diagram. And I'm going to start with the cellar floor. So for the cellar, we need a house trap. So I'll also copy this storm drainage system along with the building house trap here and this line. We don't have a pump, so I'm going to omit everything coming out of the pump, including the vent and the discharge. So I'm going to copy this, copy the note, copy this, the fresh air intake, this as well, and the note here. So we'll move this over to our sanitary riser diagram.